guys, keep in mind that, when you have time in class, that's a great time for you to ask me for help on something that, you didn't get a chance to ask me about from previous days. Work on any homeworks that you weren't able to finish. You already know what one of the 2 assignments is I'm going to be checking on Tuesday, which is that worksheet. Did you finish it? Do you need help with any of it? Okay, so use your time wisely. So I really like this lesson because it is a bunch of different word problems. And at first we, including me, look at word problems and we're like, oh, but they're obviously a part of our world. These and most of the word problems we do in here are related somehow to science. That's why we were talking about chemistry. And so what we're going to do is just do a couple examples together. You have a very short assignment. But what I want you guys to concentrate on is really like reading a word problem. Like what I do when I read a word problem is I read it I skim through it and I try to zero in on like what the formula is. Then I go back and kind of fill in the blanks. Okay, what are all those variables that I'm looking for? What's this question about? And then did I answer the question in the end? So here's what's a little confusing about today. So please listen to what I'm going to say. I've said it all day and still people are confused. They're giving us some formulas on this page that we need for later on in the lesson, for like your homework, okay? So you may have to flip back to this page. That's it. That's all I'm going to say. That's all that is really important. If this was like, you don't have to memorize any of these formulas, all right? If it were a test that I give you or the AP exam, everything that's like written in here would be given to you. Just when you get to the homework, they took a few shortcuts and didn't type all that again. They just like gave you the variables and stuff like that. So I'll point it out when we get to it, but I just want you to know you're going to have to come back to this page. That's okay. You can flip back. All right. So we're going to do, I'm not going to do this problem with you that we have in our notes, but it's like number 3 in your homework. And this is one of the examples of what I want you to remember. This formula here they give us looks like it has 2 variables, right? X and x sub 0. And it measures the magnitude r of x. Magnitude is represented by r of x of an earthquake. They give you some like distractor numbers in here, 0.001 and 100. Those are not part of the formula at all. You're not plugging those in. If you read it carefully, you'll see it's just explaining where they came up with some stuff. But here's the important part. X sub 0 is 10 to the negative 3. It tells you in the description it's not plugged in. Us math people, if there's something that's constant, that's always in a formula, we put it in there, okay? Like Pythagorean guy, or any of the other people that make up those formulas. In science, sometimes they do things a little bit differently, okay? But x sub 0, every time you use this formula, which will be 1 time on number 3, x sub 0 is 10 to the negative 3, and you'll plug it in. But if you didn't read this, you wouldn't know that. And a lot of people ask me about it later, and it's okay. I'll still answer you and not make you feel bad, but I'm just kind of trying to hit most of you now. We're going to do an example that has to do with pH scale model, so I'll come back to that, but it's like number 5 and 6 in your homework. We're not doing Newton's law of cooling. And example 1 we are going to do, which is like the last 2 problems in your homework. So that covers all 5 problems, all right? But stay with me for a few minutes. Here, this problem is really important. The way you see it typed out here is the way you would see it on a test or on the AP exam. They skip to like the suppose part in your homework. So you will have to go back and read that first sentence. And that first sentence is so important. A satellite is launched from a spacecraft and will reach a stable orbit 300 kilometers above Earth if it reaches a velocity of 7.7 kilometers per second. What does that mean? Okay, that's a fact. Okay, interpret that. That's so important to understand the homework. We need our, I'm not sciencey, so excuse my words here if I'm not saying things perfectly, to keep that satellite orbiting the Earth, which is at 300 kilometers, that's where it's stable, 300 kilometers above the Earth. It has to have a velocity of this. That's the goal. The goal is 7.7 kilometers per second, okay? We don't ask where it came from. We just trust the science people. So here's a rocket. So we have a rocket taking it up there. Suppose a rocket has a mass ratio R of 26, and this is the part you guys are missing. There's some differences in our notes today. Exhaust velocity, yours doesn't say the C for some reason. So you might want to write that. That means pick up your pencil and write it. So exhaust velocity is c. And a firing time of 120. So use the formula for a rocket's maximum velocity. Here it is. There's the T, there's the C, there's the R, to determine whether the satellite will achieve a stable orbit above the Earth. So we're going to plug all those numbers in and interpret the answer. Okay? So V of T, and T is 120, equals negative 0.0098 times 120 plus the exhaust velocity is c, which is 2.85, natural log of 26, which is our mass ratio. And this is one of those nice simple formulas. You can put it in your calculator left to right, type it on in. You can go ahead and do that if you want, or you can trust me. And I'm just rounding out to a few places. One more thing about today, how it's kind of different. There's no real rule about rounding today. On a test, on an AP exam, you'd be told what to round to, okay? So don't stress too much about the rounding today. So what we got when we put this in our calculators, typed it in left to right, that's natural log, not log. So if you get something different, common mistake on this problem is they put log in instead of natural log, okay? That's the velocity when we have all those variables plugged in. Is that high enough, fast enough? What's the word? I don't know. That's where I trip over science stuff. To keep our satellite in orbit. Is it, what's the word, people? Fast enough? Is that the word? Fast? That sounds good. Is that fast enough to keep it? Yeah. Because 8.1 is clearly greater than 7.7. So yes, we good. That one's good. Okay? So you're going to see question 1 and question 2 are going to be this same type of problem, but that first sentence is what's really, really important. And it's confusing, granted, it is confusing because you start looking at your homework, so it's people that probably don't pay attention during notes, just kidding. But you start doing the homework, you're like, what are they talking about? They're talking about this, okay, so you will have to come back to this. Look at example 2. The amount of energy E in ergs. Yes? Hello? Hi. Hi. Yes? Is it urgent right away, or can she come in like 10 minutes? Okay, great. Thank you. Okay, I'll forget. All right, so the amount of energy E in ergs that an earthquake releases is related to its Richter scale magnitude, M. And there's that a formula. I don't know that formula. Do you know that formula? And on February 5th, 2023, an earthquake measuring 7.8, there's that magnitude, M, on the Richter scale struck southern and central Turkey. How much energy did the earthquake release? Okay, so let's plug in. We have log of E, right? And E is what we want. How much energy, which they're calling ergs, letter E, is 11.8 plus 1.5 times that magnitude, right? Let's put it in my calculator. 11.8 plus 1.5 times 7.8. So I put that in my calculator and I get log E equals 23.5. Is that the answer? No. This is a log equation. What makes it a log equation? Well, it makes it an equation because it's got the equal to sign in it, and it's got a log in it, so it's a log equation, right? We've been solving these all week. And when we have to solve a log equation, we have two different types, right? We either have logs on both sides that you cancel, or you rewrite it in its other form. What is the base of this log? 10, right? If you don't see a number there, we know it is 10. So we will rewrite it in its other form. So E will equal 10 to the power of 23.5. Let's go a step further with it. Now, I think we've seen answers like this on our calculators before, but let's talk about it. This is the way your graphing calculator shows scientific notation. What does that E stand for then? 10. It's like 10 to the power of exponent. You're right. Oh, I never even thought that was E for exponent. Anyway, it is, I guess. And let's not be too stressed out about what to round to on this. 3.16 times 10, where you see the E, just put a 10. So this is a really big number. This is, take that decimal point 23 places to the right, which obviously we don't, even on these screens, we don't have enough room. So that's what scientific notation looks like on your calculator. Okay? So that's how much energy it released. A lot. Right? Okay. One more question, and that's the pH question on the top of the next page, which is different than mine for some reason. So do me a little favor, and just, we're going to do mine, just because I haven't had a chance to even look at what you guys have. It's the same idea, that mine are just two different things. And we're going to find the hydrogen ion concentrations of apple juice and whole fat cream. So just, you can just write it down real quick. Just that last line. You don't need all of it. So let me read from the previous page the pH scale model. It's a scale that measures how acidic or basic a substance ranks. The scale ranges from 0 to 14, where 7 represents neutral, and each whole pH value below 7 is 10 times more acidic than the next higher value. I think we say H positive for that. Does that sound right? I kept saying H plus. You say plus, not positive? So this morning they were like, no, it's H positive. I'm like, okay, whatever that is the concentration of hydrogen ions measured in moles per liter. Okay? Here's the formula. The formula is pH equals negative log times the concentration of hydrogen ions. Okay? Nice little baby formula. So we're going to find what H positive, H plus, is for apple juice and cream. So we're given the pH, we're just going to plug into the formula. So, starting with apple juice, which is 3.49, sorry. Now here's one of those moments where, as math people, we're going to discover that what we really would have liked to see the science people do is make this negative and this positive. Since every single time we do this, we're going to have to multiply both sides of the equation by a negative, because we're going to, I get ahead of myself. This is a log equation just like the last one we did, right? The word log is in there. There's an equal sign. We don't have logs to cancel. We're going to write it in its other form, base 10 to the power of this. But you can't do that until we get rid of the negative. Okay, so how do we do that algebraically? We multiply both sides by negative 1, divide by negative 1, whatever you want to do. Bottom line is, that will become positive, that will be negative. So you have to do that every time. You don't have to show the step, you just have to know that you did it. You and I know why and how. Okay, but they didn't do that, so we just deal with it. All right, so that would be 10 to the power of negative 3.9 equals H plus. And just like the last one, let's take it a step further and get a little better idea of what the answer is by doing 10 to the power of negative 3.49. And there's that scientific notation. So that's also 3.24 times 10 to the negative 4. So it's a small number, right? It's 4 decimal points to the left. So that's apple juice. So it's pretty acidic. It's somewhere between 0 and 7. Okay, cream, same idea. Cream is 6.62. Oh, wait, is that the right way of thinking about it? 6.62 equals negative log times H plus. Again, deal with that negative. Multiply both sides by a negative to get rid of it on the right-hand side. So 10 to the power of negative 6.62. 2.40 times 10 to the negative 7. So I think I said that wrong before. The pH is what we look at. And I was surprised that cream was considered in the acidic. Does that seem right? Like below 7? Does cream have some acid in it? My science people know? Okay. I failed chemistry, so I did. That's why I'm not a nurse. Okay, so that's the end of the notes. Let's look at the homework. Nice and short. One through 3, 5, and 6A. So just part A of 6 is what that says. You will need to flip back, remember. So that would make sense that cream is. So what's not acidic? What's something above 7? Oh, clean. Soda? Oh, yeah. You know where to go, hon? Okay. Bleach is basic. Okay. And I would have thought that would be acidic. I don't know things like that. Okay. You all have the assignment written down so I can move it? Remember, the goal is 7.7. Velocity of 7.7 is the goal. Okay, I am here for you, whatever you need. try to find T, right? You're solving for T. Look at what D is. 7.7. Why? That's your goal. How much time will it take you to get to that? He's got his homework done. The calculators are right here. It's actually on the floor. But he's got it all done. Come on.